Hello everyone, this is Dr. Dhiman and in this video we will learn about the parallel resistances. Here I have shown three resistances R1, R2 and R3. So we will find out the characteristics of these parallel resistances. There are mainly five characteristics. We will see one by one. The applied voltage is capital V. The total current is capital I, and these branch currents, that means at this point the current will divide into these three branches. Okay, first branch, second and third. So I1, I2, I3, these are the branch currents. Here we have applied this total voltage is capital V. These currents will flow and come through this part to the negative terminal of this battery. So there will be same amount of voltage drops across these resistances. So the first characteristic is same voltage acts across all parts of the circuit. That means here we'll have the voltages across this resistor. Suppose VR1, VR2, suppose VR3. These are the suppose three voltages across these three resistors. So these voltages will be exactly similar. Okay. So what we can write, if VR1 is the voltage across resistor 1, this will be equal to VR2 is equal to VR3. This is the first property. That means the voltage across the resistors. So using Ohm's law, we can write this is the voltage across the resistance R1 is I1. So what will be the voltage across this R1? So it will be I1 R1 using the Ohm's law. So we can write here this is I1 R1 equal to I2 R2. This I2 is the current through the resistor R2. So here we'll have I3 R3. So these values, that means the voltages across all parts of the circuits will be the same. So this is the first characteristics. Second characteristic is different resistors have their individual current. That means depending on the values of these resistors R1, R2 and R3, the amount of current flowing through the resistors will be different. If the resistances have higher value than the another, then it will have lower current, because the resistances oppose the flow of electrons. If there are lesser number of electrons, then the current will be lesser. Okay, so in the second point, the different resistors have different current. That means here we have across all the resistors we have voltage V. So different resistors have their individual current. What will be the value of I1? I1 is the current flowing through resistor R1. Okay, so what will be the current? So voltage across the resistor is capital V for all the resistances. Here we can see voltage is capital V. This is the capital V total voltage we have applied across all the resistances. So we have V equal to I1 R1. So what will be the current value of this I1? We have across this R1 voltage, we have the voltage is capital V. So we can write it as I1 is equal to capital V divided by R1. Then we have this I2. I2 is the current flowing through resistor R2. It will be equal to V by R2. And similarly, I3 is equal to V by R3. Okay. These resistances R1, R2 and R3, they may be different. If they are same, that means if we have R1 equal to R2 equal to R3, then it will be I1 is equal to I2 equal to I3. This is the second property. That means different resistors have different individual current. That means if the resistors have different value, then the current values also will be different. In the third property, we have branch currents are additive. That means we can add the currents of the branches. That means here we can see these are the three branch currents I1, I2 and I3. So these currents we can add. If we add these three currents, it will be equal to the total current, that is the I, or the equivalent current, or the total current of the circuit. So we can add these currents to get the total current of the circuit. So here we can write that is I is equal to I1 plus I2 plus I3. These are the three currents flowing through the resistors R1, R2 and R3. So the total current we can find out through the addition of these branch currents. Again, we can write it as I1 is equal to V by R1 plus I2 is equal to V by R2, and I3 we can write it as V by R3. So branch currents are additive. These are the current values of these three branches. Okay, now let us go to our fourth property. Conductances are additive. Conductance is the opposite of the resistance. Suppose 1 by R1, if 1 by R1 is equal to Z1, if 1 by R2 is equal to Z2, 1 by R3 is equal to Z3. Suppose these are the conductances of the resistances R1, R2 and R3. Then what will have? According to the fourth property, we have conductances are additive. That means the total conductance, if we assume it to be capital Z, what will have? It will be Z1 plus Z2 plus Z3. Now, total conductance will be what? It will be opposite to the total resistance. If we assume the total resistance to be R, and Z1 will be 1 by R1, and Z2 will be 1 by R2, and Z3 will be 1 by R3. So, this is the actually formula. In parallel connection, we have the total or the equivalent resistance of the circuit will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. This R1, R2 and R3 are the individual resistances of the three branches. Now let us go to our fifth property. In the fifth property, we have the powers are additive. So powers are additive means V into I. This is the total power. Power through the first branch. So what will be the power? It will be the current square into R. So I1 square into R1. So for this branch, we'll have I2 square R2. And for this branch, third branch, we'll have I3 square R3. Because we have power is equal to I square R. This is the formula we have to use. So here we have powers are additive. This means this is the total power, or we can write it as the equivalent resistance I square into R. This is I square. I is the total current and R is the equivalent resistance of the three resistances. Okay. So what will be the value? This will be I1 square R1 plus I2 square R2 plus I3 square R3. So this is the total power, and we have the individual powers I1 square R1, I2 square R2, I3 square R3. So if we add the individual powers, so then what we'll have? We will have the total power of the system. So this is all about the parallel resistances. That means the resistances are connected in parallel connection. So we have seen all the characteristics. If you have any question, please put it in the comment section below. Also like and subscribe to my channel. Also do not forget to share my videos with your friends. Thank you.